Here are a couple of easy questions that revolve around gradients using the gradient formula. And if you remember, the gradient formula is gradient m is the two y coordinates, difference between the two y coordinates divided by difference between the two x coordinates. And this is a very important formula in coordinate geometry because a lot of the things that we do revolve around gradients. In fact, 3/4 of it. Now, in part B, we want to show that ABCD forms a parallelogram. Now, the definition of a parallelogram is two pairs of opposite parallel sides. So we need to find the gradients of each of the sides. So, gradient of AB is going to be 9 minus 3 over 6 minus 11, which is negative 6 over 5. The gradient of BC is going to be 3 minus 0 over 11 minus 0, so that's just 3 over 11. The gradient of CD is going to be 0 minus 6 over 0 minus minus 5, which is minus 6 over 5, which is the same as the gradient of AB. And finally, the gradient of DA is going to be 6 minus 9 over minus 5 minus 6, which is 3 over 11, which is the same as the gradient of BC. So because the gradient of the opposite sides are equal, the opposite sides are parallel, and therefore it forms a parallelogram. Now, for part C, we need to show that there's a pair of opposite parallel sides that does not have the same gradient. So, the gradient of AB is going to be 5 minus 7 over 2 minus 3, which is just positive 2. The opposite side is CD, so that's going to be minus 1 minus 2 over minus 4 minus minus 5, which is going to be minus 3 over 1, so that's going to mean negative 3. And we see right there that the opposite sides do not have the same gradient. Therefore, they are not parallel, and so it can't be a parallelogram. So this all leads back to remembering the properties of your quadrilaterals and ensuring that you always find the gradients of all sides, remembering the very important gradient formula.